Right. 7 now. So what's happening here is you have two pendulums, a big one and a small one, and the big one is 100 grams and the small one is 20 grams. So what happens is here, this one is a 100 gram, so that's a 0.100 kilogram mass, and then up here there is a 20 grams, so that's a 0.020 kilogram mass, and the height here is 0.3 meters, and what happens is this will swing down and smash into this one. Oh, not only do they smash, but they stick together as well. So you can think of like some glue here and here. The two masses then stick together and move as one object. First question. What will be the speed of the small mass before it hits the big mass? Right, does anybody know what formulas or ideas or principles I can use here to get me that information? The speed of the small mass before it hits, yeah? mgh again, the energy, yeah. Here, when the ball is here, we can say its kinetic energy will equal its potential energy here. So a half mv squared equals mgh. Well, the m's cancel, that's great. So you end up with v will equal square root 2 times g times height, which is 2.426 meters per second. Okay, can I do the next part now? Yep. So next, the two masses stick together and they move away together. We've seen this problem twice before. What do I need for that one? Not moments, momentum. Conservation of momentum. So before the collision, the momentum is 0.02 multiplied 2.426. Then after the collision, the momentum is 0.120, the combined mass, times v. We don't know this v. It's a different v now. Don't be confused, I'm not saying the same v. 0.02 times 2.426 divided by 0.12. So now we get the velocity when they're together. And this is the velocity just before they collide, 0.4043 meters per second. All right. Next part. Calculate the percentage loss of kinetic energy. So first we need to work out the kinetic energy. So before the collision, the kinetic energy is a half m v squared. And then after the collision, the kinetic energy is a half m v squared. What's wrong, Joshua? That's the Oh, that's the mass. Huh?
No.
No, it's not. Yeah, what the heck is that? Oh yeah, sorry, I'm way off. Thank you, Joshua. This here should be 0.120. Yes? Okay. Kinetic energy before the collision. A half times 0.02 times 2.426 squared. That is 0.05885 joules. The kinetic energy after the collision should be smaller. If it's not, you've done something, or I've done something really wrong here. 0.404, what the heck was that number? 3. Tiny. 0.009808 joules. So, how much was lost? Well, that would be 0.05885 minus that number. So there was 0.049 joules lost. They just want that as a percentage. So I'll do 0.049 over 0.05885 multiply 100. So as a percentage now, that's a lot. 83.3% was lost. A lot of kinetic energy lost here. So last part here. Just, sorry, I didn't write it here. This is part C here. Okay. Right, last part here, part D for 1 mark. What do you think happened to this kinetic energy? Where did this kinetic energy go? It didn't just disappear. Where did it go? Yeah. The 83.3% loss in kinetic energy was due to heat and sound. Yes. What I mean by that is the kinetic energy changed into heat and sound energy. Just 1 mark for that.